Good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Pekar. Unit 1, Video 3 we're looking at today. Learning target is I can solve inequalities. And this is a lot of review for you guys, so this is something you should probably pick up quickly. Okay, just working with inequalities a little bit, talking about less than and greater than. Cooney is trying to decide between two rate plans offered by a wireless phone company. Plan 1 is $35. You get 400 minutes, and then it's 40 cents for each additional minute after 400. Plan 2, $55, but you get 650 minutes included. Each minute after 650 minutes is 35 cents. So just looking at this a little bit, first is this. Write inequality to compare the price of Plan 1 to the price of Plan 2. Well, just the price itself. Plan 1 is $35, and Plan 2 is $55. And if you weren't worried about how many minutes you were going to use, I'd say you'd probably go with Plan 1 because that is less than Plan 2. 35 is less than $55. Some people struggle with inequalities a little bit. Looks like a little arrow, kind of. The arrow always points to the smaller figure, and the opening opens up to the bigger number. So 35 is less than $55. What do we got here for number 2? Write inequality to compare the price of additional minutes for Plan 1 compared to the price of additional minutes for Plan 2. Well, Plan 1, it's 40 cents. Plan 2, it's 35 cents. 40 cents is greater than 35 cents, so I'd say 40 is greater than 35 cents. Cooney knows that she'll use no more than 40 minutes per month. Which plan is best for her? Well, if she's not going to use more than 400 minutes per month, these don't really matter. Plan 1 is less than Plan 2. In other words, 35 is less than 55, so Plan 1 would be the best bet. Okay. Now we got to do a little work. If she uses 1,000 minutes per month, which plan is best for her? Well, figuring out Plan 1, if we use 1,000 minutes, it's going to be $35 to begin with, plus, well, 400 minutes are included in the plan. The extra 600 minutes that she's going to use are 40 cents a piece, so it's going to be 600 times 0.40, or just 0.4. That's Plan 1. Plan 2 is going to be $55 to start out with, plus 650 minutes are included. 1,000 minus 650 is 350. So 350 minutes times 0.35 or 35 cents. So figuring out these two plans, well, we just plug these into our calculator here, TI-84. So let's do that. And we got Plan 1 is $35. Let's clear this out first. 35 plus 600, then parentheses, and 0.4. 0 if you want to put that in there, and parentheses, and then hit enter, and you should get your answer. And that's $275. So Plan 1 is going to be $275. Plan 2 now would be $55 plus, what is it, 350 times, so we'll just do parentheses there, 0.35, and hit enter. And that's $177.50. So 275 is greater than 177.50, so I'd say greater than If I was choosing a plan I was going to use 1,000 minutes, it would be definitely plan 2 would be cheaper. Now most of our phones and rates are different than this now, but this is kind of what it was back in the day when cell phones first came out. So we'll get rid of this. Move on to the next one. Solving inequalities. Follow the same steps as when solving equations, except if you multiply or divide by a negative number. Right here, if you multiply or divide by a negative number when you're working with inequalities, you flip or reverse the inequality symbol. A quick little example would be negative 3x is less than 12, we'll say. Now, if I want to solve this for x, I got to get rid of the negative 3 here. It's multiplication. Opposite operation would be to divide by negative 3. Now, some people divide by positive 3 because that's the opposite of negative 3, but a negative divided by a negative is a positive, and that's what we want. These cancel out to 1, but I divided both sides by a negative here, so I got to flip my inequality symbol to greater than, and that's negative 4, and that's my final answer. Now, if it would have been 3x, well, let's just make something else. How about 5x is greater than, I don't know, negative 10. In order to solve this, you divide both sides by 5. Now, I know that this is negative 10 right here, but I'm not dividing by negative 10. I'm dividing by positive 5. So I wouldn't flip my inequality symbol. This would just still be x is greater than negative 2. So that's the difference. Are you dividing both sides by a negative or not? If you're not, you don't flip. If you are, you would flip like we did over here. We're going to graph our answers on the number line. And right here, to graph inequalities, use open dots for less than or greater than, and solid dots for less than or equal to or greater than or equal to. Then you must shade in the direction that corresponds with the inequality. And we'll look at that in a second here. Here's our first one, solve and graph. Well, solve just like you would an equation. We're going to get rid of the negative 9 first, because 11 is attached to the y. That's your variable term. So get your variable term by itself. Adding 9 to both sides, I get 11y is greater than 22. Finally, just dividing both sides by 11, I get y is greater than 2. I don't have to flip my inequality because I didn't divide or multiply both sides by a negative. As for graphing this, here it is. You got some dashes here for each side. I just take your answer, which is 2 in this case, and I'm going to put it right here, 2. Now I know this would become 3, 4, and 5 over here. This would be 1, 0, and negative 1. So I have numbers on both sides of 2. And if we're going to graph y is greater than 2, you got to think of a number you could plug in for y that would make it a true statement. In other words, what are some numbers greater than 2? Well, 3, 4, and 5 are greater than 2. So being it's just a greater than symbol, I'm going to circle a 2 because that's where my problem starts, and I'm going to shade towards the numbers that are solutions. So we're going to go to the right. Y is greater than 2. There we go. Same thing here. Get the variable term by itself. We don't have to simplify either side here. It's not a lot of work. So just subtracting 9 from both sides. 7x is greater than or equal to negative 21. Divide both sides by 7, and x is greater than or equal to negative 3. Now, it was negative 21, but we're not dividing by the negative 21. We're actually dividing by positive 7, so we don't flip our inequality symbol. Graphing this bad boy. Negative 3 is where I'm going to start with in the middle. Let's go, this would be negative 2, negative 1, and 0. This would be negative 4, negative 5, and negative 6. What are some numbers greater than negative 3? Well, as you go to the right, you're on the number line, your values increase. So negative 2, negative 1, 0 are all greater than negative 3. So So I'm going to circle it. And because it's greater than or equal to, I shade that in because negative 3 is part of the solution also. And we go to the right. Okay, we got a fraction here. So this is going to be a little bit more work. It's not that bad. You got to go piece by piece, basically. And you kind of work away from the n. 2, which is connected to the n, 2n, that's your variable term, is the last thing you're going to take care of. 1 is the furthest most out. Then you're probably going to take care of the 5 because you're dividing everything by 5, and then you're going to take care of the negative 6, and finally the 2. So putting this into play here, I would subtract 1 because it's not part of my fraction that I'm working with right now from both sides. So 2n minus 6 over 5 is greater than negative 1. The key here is this. This whole thing you're dividing by 5. So to get rid of the fraction, it's being divided by 5, the opposite of divided would be multiply, basically both sides by 5, or 5 over 1, and these would cancel out. I'm just going to multiply by 5 over here because it's not a fraction on the right-hand side. There is no denominator now except for 1, so I can say 2n minus 6 is greater than negative 5. And from here, you guys should be able to do it. Adding 6 to both sides, I get 2n. I get 2n is greater than 1. Dividing both sides by 2, I get this. N is greater than 1/2. Or you could say 0.5 right as a fraction. I'm going to move the number line over here. Now, that's a fraction. It's between 0 and 1. So if I'm going to graph this, I'm going to put 0 here, 1, 2, 3, negative 1, negative 2, negative 3, and we're actually working with this point right here, 1/2. It's greater than 1/2. I know 1 is greater than 1/2. I know 2 is greater than 1/2. So we're going to the right. Solve and graph your solution on the number line. Okay, looks like I'm going to have to divide by a negative here. But before I do that, I'm going to get rid of the 14, so I'm going to subtract 14 from both sides. That's a negative 8n, because you're subtracting it, is less than or equal to negative 14. Divide both sides by negative 8. Now, I divided both sides by negative 8, so I got to flip my inequality symbol. This is going to become n is greater than or equal to. Well, you can reduce that as a fraction, or you can just divide it and get a decimal. I don't really care either way. So I'm just going to do negative 14 divided by negative 8. We'll just write it as a decimal then, 1.75. So n is greater than or equal to 1.75. Okay. Graphing this now, 1.75 is between 1 and 2. 3, 4, 0, negative 1, that should be enough. So 1.75, 1.5 would be right in the middle. So 1.75 is about right there, 1.75. It's greater than or equal to, so I'm going to shade it and color it in. 2 is greater than 1.75. 3, 4, they're all greater than 1.75. So I'm going to the right. Writing some inequalities. Okay. We're not going to solve this. We're just going to set it up. I want you to be able to write inequalities also. The key is like more than and less than is usually adding or subtracting. But as soon as you put is, that's an in. As As soon as you put is no more than, this represents your inequality. I want you to think about that. Is no more than. Use examples like, I'm going to say I am no more than 6 feet tall. Could I be 7 feet? No. Could I be 5 feet? Yes. So this is a less than or equal to symbol. So when you read number 9 here, it says twice the sum of a number is no more than 3 times that same number increased by 11. Is no more than is less than or equal to. Now, this is going to be the first half of our inequality on the left-hand side. Twice the sum. As soon as I say twice the sum, I'm saying twice the sum of what? So it's going to be in parentheses. Twice the sum of a number and 5. So those are the two things I'm adding. I'm going to use n, and that's fine. The second part here, it says, which will be on the right-hand side of my inequality, 3 times that same number increased by 11. The same number would be n. We don't know what that number is, so we're just going to call it n again. 3 times that same number, so 3 times n, same number is increased by 11. Now we're adding 11. There we go, and we're done. That's our first inequality. Nine less than a number is at most, okay, here it is at most, so I'll use my height again. I am at most 6 feet tall, so could I be 7 feet? No. Could I be 5 feet? Yes. So this is a less than or equal to. I could also be 6 foot. If I'm at most 6 feet tall, I could be 6 foot. So this is less than or equal to. Is at least 6 feet tall means I could be 7 feet tall. That would be greater than or equal to. Anyway, 9 less than a number. So I'm subtracting 9 from a number, and minus 9 is at most. That same number divided by 2. Well, the same number is n, and that's divided by 2. Now, some people say n divided by 2. Usually when we write it algebraically, we're going to write division as a fraction, so we'll keep it kind of looking like this bad boy right here. Here's an example you might see on this year's ACT test. It says homemade bracelets are for sale for $4.75 each. Which inequality can be used to find how many bracelets Caitlin can buy for herself and her friends if she wants to spend no more than $22? Well, it's A, B, C, or D. I want you to hit pause. I want you to try this on your own. Okay? What we got here? Well, I'm going to say B is the number of bracelets they're selling. So 4.75 times B is going to be how much money they make. Now, she can spend no more than $22. No more than. So can I spend 23? No. Can I spend 21? Yes. So this is an example of less than or equal to 22. And I believe you should have A. Good job. Solving word problems using inequalities. The Middletown High School girls basketball team wants to make at least $2,000 on their annual mulch sale. Teams can make $250 on a bag of mulch. How many bags of mulch should the team sell? So we're going to use B again for bags of mulch. How many bags are going to sell? Well, it's $250 for each bag of mulch. Wants to make at least. So this value right here, how much money they make, they want it to be at least $2,000. So could it be $3,000? Yes. Could it be $1,000? No, that's not what they're looking for. So we want greater than. And they could make exactly $2,000, so it's going to be greater than or equal to $2,000. To solve, we're going to divide both sides by 250, and B is greater than or equal to, what do we got here? Grab my calculator. Where you at? There he is. So 2,000. Let's clear this out. 2,000 divided by, what is it, 250. 800. So the number of bags of mulch has to be greater than or equal to 800. If they sell 800, they'll get 2,000 exactly. If they sell more, they'll make more. Hey, if you haven't got a TI-84 calculator, some kind of TI-84, I would suggest getting that in the next couple of, well, we'll give you a week, because we're going to start doing linear equations, and you're going to want your graphing calculator TI-84 for those linear equations. Anyway, have fun on the worksheet, and peace out, Boy Scout.